everybody, with our Go Blue for today. Number one, what type of wave has the lowest frequency and the highest frequency? This is based on yesterday's chart. And then what type of wave has the shortest wavelength and the longest wavelength? Let's see here. Angel, did you maybe have answers for those questions? Perfect. And then what do we have for number two? Radio. Perfect. Again, great job. Great job. So as Angel just noted, guys, we have the frequency, right, is how frequent the waves are approaching a source, right? So radio waves are spread out. They're less frequent. So again, our lowest frequency is radio waves, whereas gamma rays are high energy. They're like a radio wave is like 1, 2, 3 with the waves, right? But a gamma ray is like 1, 2, 3, 4, 5, right? It's going to be back to back to back. So that's going to be the highest frequency. Then on another note, let's get into wavelength. Because the radio waves are stretched out and longer and they're less frequent, that means we have a greater wavelength. So the highest wavelength is going to be, or the longest wavelength are the radio waves. And because the gamma rays are back to back to back, they're all kind of pushed together. They have very short wavelengths. So we're going to say the shortest wavelength is the gamma rays. Anybody have any questions on that? Questions on that before we move on? Okay, let's move on then to our, again, just reemphasizing this. We've got to know this chart for tomorrow. This is super important. Got to know the colors Roy G. Biv, or know this chart for the test next week. And we got to know the different types of waves: radio, microwave, infrared, visible light, ultraviolet, X-ray, and gamma ray. Go ahead and update your table of contents if you need to. We have 13 through 15 are going to be star life cycle. 13 through 15 are going to be star life cycle. Okay. Wait till our in-person students look like they're ready. Then let's go ahead and move on to our first question of the day. Maybe the only card question we see today, all about redshift, right? So in redshift, wavelength blank while frequency blank. Does wavelength increase? Okay, here we go. A, is it increases? B, decreases? C, increases? Or D, increases, right? So what changes in redshift with the wavelength and the frequency? If you look at the color red, you can think about it from that point of view. Answer in the chat, A, B, C, or D. Give you guys about 20 more seconds for participation credit. All right. Thank you, Angel. Thank you, Isaac, Sanaya, Yorkies. I still need more people. Lakia, Irina, great. Everyone's really answering the questions fast. Really good. 10 more seconds, everybody. 10 more seconds. Only question of the day. I'm thinking, right? 5, 4, 3, 2, 1. Really, really great job, everybody. The answer was letter C, right? Again, if you're left on red, that person's probably distancing themselves, right? They don't want to respond back. So I just say that left on red because redshift is going to be going away, right? Where stars move away. If the stars are blue, they're going to you. So yeah, C was the answer. The waves are going to increase in their length because they're getting further away. Frequency is going to also wavelength. My bad. Wavelength is going to increase because the waves are being stretched out and going further away, and the frequency, again, they're going further apart, so it's less frequent. Letter C. Props to Angel, Irina, Lakia, Yorkie, Sanaya, and Isaac for getting the right answer. Really good job, everybody. Okay, moving on to our only video questions of the day on page 13. I need you to write number 1 and 2. We're going to compare the questions in yellow. You need to write these down on page 13, guys. We're going to compare our star, the sun, to giant stars, okay? So I want to know for number 1, what stage is our star in, the sun, right? And what stage will it die as, right? Because stars have a life cycle, they die as well. So what's going to happen to our star through its lifetime? And then number 2, what stages do larger stars go through when they die, right? So giant stars, what happens to them instead? What happens to them instead? They have very different results, very different life cycles. So I'm going to give you guys a minute while my in-person students write this as well, and we'll begin our first video of the day with the video questions. What am I become at the very end of his life?
I've never like die out.
You might have gone for this a little bit, so we'll get into what happens to you. Right? All right, everybody, our in-person students are ready. We just talked about how stars sometimes end, right? So we talked about stars exploding. Angel, you remember what the name of stars exploding is called? Okay, it's called supernova, guys. We call it a supernova. So let's find out, will the sun explode into a supernova? Let's find out. Let's find out with our first video of the day. So the first part of number 1, the video does not answer, but the second part it will, and all of number 2 it will answer. Let's check it out. I'll help you out with the first part of number 1.
Like fireflies on a still summer night, they gently dot and illuminate the infinite velveteen sky. Stars, be they millions or billions of years old, are all born in nebulae, clouds of dust and mostly hydrogen gas. Within these stellar nurseries, stars begin life as protostars, or hot cores formed by the collection and collapse of dust and gas. As the protostars become hotter, hydrogen nuclei inside of the cores begin to fuse and create helium. It is this chemical reaction, thermonuclear fusion, that generates a star's heat and energy and causes it to shine. Stars are categorized by a number of characteristics. One of these classifications is by surface temperature. Called spectral classes, these 7 major groups range from the coolest stars, which are designated as M, and up to the hottest stars, which are designated as O. Stars are also classified by the amount of light they emit, or luminosity. Called luminosity classes, these 9 major groups range from the small, less bright white dwarfs to the large and extremely bright hypergiants. But no matter their luminosity or surface temperature, all stars eventually burn through their hydrogen fuel and die out. Less massive stars, such as our Sun, release their stellar material into space, leaving behind a white dwarf surrounded by a planetary nebula. More massive stars instead blast matter into space in a bright supernova, leaving behind an extremely dense body called a neutron star. But the most massive stars, stars that are at least 3 times our Sun's mass, collapse into themselves and create a bottomless well of gravity, a black hole. But from the remnants of stars, heavier elements are cast into the universe, and it is this stardust that formed the seedlings of life itself.
All right, so a good little preview or rundown of different star life cycles as you saw there, everybody. So for number 1, what would be the last stage of our star, Angel? A white dwarf, right? So basically, also super important, I didn't say this in the video, our sun, our star, is going to be categorized right now as a yellow main sequence star. A yellow main sequence star. What do I mean by that? I mean, it's not a small star or not medium. It's like a little less than medium. And yes, it is a yellow in color. All right. And yeah, eventually our star will become a red giant, but only temporarily. it will shed its red outer layer, and it will then become a white dwarf. Basically meaning that all that will be left over is just the core of the star. The core of the star as it fizzles out. So will our sun explode? No, it won't. It'll just fizzle out. It'll just fizzle out. So no need to worry. We probably do not need to worry about the sun exploding. Number 2, what stages do larger? Okay, so what happens to larger stars that we just talked about? Supernova, and then what are the two things they get from that? Yeah. Exactly, perfect. So you only get supernovas, star explosions from giant or large stars, and when that does occur, they'll form either a black hole or a neutron star. So we'll get into more details on the differences between the neutron star. That's a new topic, right? Unrelated to the popular Nickelodeon show, Jimmy Neutron, right? So that was a fun show. Remember Jimmy Neutron? Okay. Did you remember Dexter too? Or not as much? Dexter's Laboratory?
Yeah.
Okay. So in class today, I've been saying who's better, Jimmy Neutron or Dexter's Lab, and I get interesting answers to say the least. So if you have any input on that, you can let me know in the chat. And then Cartoon Network versus Nickelodeon, right? That too. All right. Let's go ahead and go to our next thing right here, which is the diagram. You guys that are online will have to copy this and draw it yourself. My students in person, they're able to just label the diagram that's printed out for them. I'm going to give my in-person students a minute, and then I'm going to explain to everybody else what we're looking at here. Basically, this is the illustration of the different life cycles of stars. I'm going to take 1 minute for our in-person students to get this down, and then I'll explain it in more detail. Again, everyone that's online, make sure you have a picture of this. You're going to copy it to page 14. You're going to copy this to page 14. So basically, we're looking at this diagram here, everybody. We're looking at the different life cycles of different sizes of stars. So the small stars, like I said, all they really do is they may change color. We see some becoming like, by the way, the earliest stage of a star is caused by a nebula and protostar. So basically, you get a bunch of star dust and star gas. Okay, it ignites and forms a baby star. We call baby stars protostars. We'll go over that in a minute. Low mass stars, small stars, they change color and then they just fizzle out into a white dwarf. Okay, medium mass stars like ours, the sun, okay, it will become a giant, but the giant phase for our star is only temporary. So we'll get larger, but not large enough to explode into a supernova. It'll shed its outer solar layer, and all that will be left over, again, is a white dwarf. So no need to worry about the other outcomes from our star. Now, the massive stars that become supergiants, right, they either, if it's high mass, become a neutron star after the supernova, or they become a black hole. And those are only the stars that are very, very massive, very high mass. Okay? So that kind of shows you the difference between those two, the smaller stars and the larger stars. Okay. So again, you're going to draw that to page 14. And at the bottom of that, I need you to write these 3 things right here. Make sure to write all 3 of these guys below the chart on page 14, comparing the different life cycles of those stars. I'll give you guys 1 second. Make sure to write this below the chart on page 14. Okay, so what do we see here? Well, here's an interesting idea. The smaller the star, the longer the star lives, right? So it's kind of like cars, right? If you have a Hummer, I think they go like 10 miles per gallon. If you got a small aerodynamic car, it's going to go like 30 or so miles per gallon. So you're basically, if you have a Hummer or a large Jeep, that car is going, you have to refill the gas in that car 3 times as much. So the same thing applies to stars. The larger the star, the faster it burns up its fuel. So the giant stars, the massive stars, they're only going to live millions of years. Okay. Whereas the medium and the low mass stars that are more efficient, they don't burn up as much gas. They're going to live billions to trillions of years. So the smaller the star, the longer the star lives. Okay, we all got that? All right. I have one more thing I want to do with you guys is let's see here. Page 15. So go ahead for my students in person. You're going to copy that down to page 15. I'm going to go ahead and show. I know you guys can't see it right now. Let me go ahead and see what I can. I think I need to show it on the screen here. Yep. Okay. So let's go ahead and stop share then. 1 second. Okay. Let me go ahead and I need to take the sheet that you guys are going to create. It's pretty easy, right? Okay. So basically, what we're going to do tomorrow is we're going to go over these different stars we've not learned as much about. So you're going to go on page 7. Again, feel free to take pictures or pause. You're going to title it by page 15, and you're going to title it Star Life Cycle Examples. Star Life Cycle Examples. So go ahead and take a picture of that if you'd like. I'll keep that up for 10 seconds. And on that page, I need you to list out 7. There's 7 total. 7 total. 7 total on the page. Leave that there. I'll leave it there, I guess. Okay. Your first 3, I'll show the first 3. Or first 4, actually. Let me show the first 4. First 4 are going to be protostar, red dwarf star, white dwarf star, and black hole. Those are going to be your first 4 examples. And we're just going to explain those in 1 sentence each. Want to know so we can differentiate these. And then your last 3 are going to be the main sequence. That's what our sun is. Red and blue giants. And lastly, neutron stars. These are the last 3. Main sequence, red and blue giants, and neutron stars. Okay. So we're going to go through the last 6 tomorrow. I'm going to give you the first one right now because it is on your vocab. All right. So I'm going to wait till everybody got what they need there. Here are the last 3 in case you didn't get those. Last 4. All right. When our in-person students are ready, I'm going to show you guys the first one because I feel like I wanted to give you a good example, and you can use it to copy down into your vocab assignment. Again, don't forget that vocab needs to be written only. It cannot be typed. Typed because of the issues with the people just copying and pasting, right? Okay. Let me go ahead and pull up the example. It will be up here. of the first one. One moment, everybody, one moment. Okay, so last one I'm going to show you today, guys. Oh, my bad. Let me fix the screen. Is the protostar. Okay, oh, my bad. Where's it at? There we go. Protostar, guys. So just write this for protostar. A contracting mass of gas. Let me see if you guys can see it okay. All right, good, good. A contracting mass of gas that represents an early stage in formation of a star. So yeah, all this is important. Make sure to have all of that. For protostar, just understand this is the earliest stage of a star other than when it's dust and gas. So after that dust and gas finally ignites, we get like a spark that kind of forms like a hot flaming disk that spins around and forms a star. Kind of gets all the gases collected. So again, think of like a protostar, like a baby star. It's like a baby star, a star that was just born. Okay. All right. That concludes our lesson so far today.